Writing and balancing chemical equations. In this video, we're going to define reactant and product, and then we're going to use these to discuss reactions, both in terms of their equations and just in words describing what's happening. We'll then use this to define mole ratio in terms of the chemical equation. We won't be doing any calculations with it in this particular lecture. We're going to save those for next time. So first, let's look at something really generic. So I just put some random letters in instead of species. So we have A plus 2B goes to C. The reactants are substances and compounds that are changed or altered in a reaction. And those are always written on your left-hand side, whereas your products are formed during a reaction and are written on your right-hand side. In this generic reaction, go ahead and try to describe what you think are the reactants and the products. So hopefully you got that your reactants are A and the B, and then that leaves your products being C. Now let's look at an actual chemical reaction and then practice balancing it as well. So here we have nitrogen plus oxygen goes to nitrogen dioxide. We need to make sure that when we're balancing these, that the number of each element on the right-hand side equals that on the left-hand side, or that the reactants are equal to the products. And we need to make sure that all of our numbers add up to do this. Right now, if you look at this one, we can see that we have 2 nitrogens as a reactant, but only 1 as a product, and so it's not balanced. There's a little bit of guess and check involved whenever you're balancing chemical reactions, but there are some things that can help you out. Generally, you're going to want to start with anything that isn't hydrogen and oxygen. That usually gets you closest to the right answer fastest. So in this case, we're going to start with our nitrogens and then worry about our oxygens. So I rewrote the equation down here just for us to use so we can see where we both started and ended at. We can see that we have 2 nitrogens as our reactants and 1 as our product. So we need to add a 2 in front of the NO2. Now our nitrogens are balanced, but by doing that, we actually unbalanced our oxygens. So if we look at our products, we have 4 oxygens now, 2 from the subscript multiplied by 2 times the coefficient. So in order to balance this, we need to put a 2 in front of the oxygen. So now we have 4 oxygens on both sides. And this is our balanced reaction. Now, what does this actually tell us? Why do we care about this? The coefficients that are in front of the elements are going to tell us the ratios of all of the species, and this is really useful. There's 2 different types of ratios we get off from this that are nearly identical. So in the example above, let's start by talking about them as individual molecules. We can say that 1 nitrogen reacts with 2 oxygen molecules to form 2 nitrogen dioxide molecules. And that's useful for us. It's good to know the ratio of individual atoms, but how we actually tend to use this more often is doing mole ratios. We know that a mole is equal to Avogadro's number, or 6.022 times 10 to the 23rd molecules or atoms or anything really. So since that's the same for every single species here, not only does this give us the ratio of molecules, but this also gives us the mole ratio. So using this now, we can say that 1 mole of nitrogen reacts with 2 moles of oxygen to form 2 moles of nitrogen dioxide. It works as both using molecules or moles. And this is really useful because it gives us something called the mole ratio, where we can say that we have 1 to 2 to 2. And those actually will work as conversion factors. We're going to talk about that more in other lectures, but we can use this as a conversion factor to convert between products and reactants. And so this is really important, not just to have a balanced chemical reaction, but to be able to do a lot of problems. We're going to be able to convert between products and reactants really in any form. So for instance, if we have a given amount of reactants, we can figure out how much we need to create a certain amount of product. Or if we want a certain amount of product, we can figure out how much reactants we need to form that much product. Or maybe we know we have a certain amount of one reactant, and we need to know how much of the other reactant we need to react it completely. There's lots of different things that we can do with this that we'll work on in later videos. So in summary, we have reactants, which are changing in a chemical reaction, and we write those on the left-hand side. Meanwhile, we have products that are formed during a chemical reaction, and we write those on the right-hand side. To balance these, we need to make sure that our total number of each element are the same on both the right and the left-hand side. There's guess and check involved in actually doing this, though generally if you start with elements that are not hydrogen and oxygen, you're most likely to solve for the balanced reaction on your first try. The coefficients, once you get a balanced reaction, will tell you both the ratio of molecules along with the ratio of the moles, and so we can use these as conversion factors to interconvert between products and reactants.